Hello and welcome to another episode of Green Shift. Today, in this episode, we are going to discuss coal gasification. Why now? Why are we discussing coal gasification? That's because the government came out last week with a large scheme worth 37,500 crore rupees. To discuss this with us, we have our colleague, Mr. M Ramesh, consulting editor, businessline. Welcome, Ramesh.
Hi, Bharat. Well, thank you.
First off, what is coal gasification?
Well, Bharat, coal gasification is simply converting coal into gas. By the way, this is not to be confused with coal bed methane, where gas exists as gas, just stuck to coal in the coal seams. That's a different thing altogether. Coal gasification is converting coal itself into gas. Now, how do they do it? As we all know, when coal burns in air, it combines with oxygen and becomes carbon dioxide. But when it is burnt in limited supply of oxygen, it becomes carbon monoxide. And when you bring in steam with limited supply of oxygen and steam, it becomes a mixture of carbon monoxide and hydrogen. This mixture is called synthesis gas, or commonly known as syngas. Syngas, by the way, is a basic building block for many chemicals. Hydrogen itself is one of them. Hydrogen. And then you can go on to make ammonia, methanol, and fertilizers and so on. Coal gasification, to answer your question, is all about converting coal into syngas.
Why is coal gasification important in today's context?
Coal gasification is very important because, particularly for India, I'm saying, because India, as we all know again, is blessed with about 400 billion tons of coal, and our annual production is something like 750 million tons, and our aim is to go to 1 billion tons. Now, even if we are not going to be in a position to take out all the 400 billion tons, coal will last for several centuries at the current rate of production. Now, but because of climate change concerns, because of global warming, we should not burn this coal in thermal power plants, for example, because it will produce carbon dioxide. Now, the question is, how do we make use of the coal and yet not muck up the environment? Coal gasification is the answer. Coal gasification can give us energy self-reliance, energy atmanirbharata. By the way, China, we are very fond of giving China as an example. China has done this very successfully. About 90% of China's ammonia production and about 70% of methanol production comes from its coal gas. Done very successfully. It's a technology that is rather well proven in the world. This is the option we have for making use of the coal without emitting carbon dioxide, or by emitting a very little amount of carbon dioxide, let me put it that way. Now, there is another interesting angle to it. I must say that very recently I had a chat with an expert in the industry, a gentleman called Athanu Mukherjee, who is the CEO of Dastur Energy, which is a very large global consultant. Now, he told me that with syngas, you can produce hydrogen at a cost of about $1.25 per kilogram, which is the dream of the entire hydrogen industry. This hydrogen is not green hydrogen because in this process, you will emit carbon dioxide, but the carbon dioxide comes out in sufficient concentrations that it is easier to capture it and put it under the ground. Now, you can do a CCUS project. With coal gasification plus CCUS, you can produce hydrogen that has been produced in a process that is not carbon dioxide emittive. So this is called blue hydrogen, by the way. Unfortunately, this point has still not been well recognized in the industry. The linkage between coal gasification and hydrogen has not been made very clear. It's not well recognized, well realized or acknowledged. So coal gasification, therefore, is very important, particularly for us.
No, then right now it's pertinent to ask this question. If you have grey hydrogen, at what cost do we produce?
Grey hydrogen is produced from natural gas. Natural gas is methane, which is CH4. You knock off the C, you end up with H2. But when you knock off the C, what happens to the C? It mixes with oxygen and becomes carbon dioxide. This process this is what is called grey hydrogen. The hydrogen that comes from this process is grey hydrogen. And it is, the cost of it is generally put somewhere around $1 to $1.5 per kg. Now with electrolysis, the best you can get is something like $3.50. I mean, again, I'm being a little liberal here with the cost of electrolyzers, the cost of pure water, the cost of electricity. To produce 1 kg of green hydrogen through electrolysis, you need 55 kilowatt hours, 55 units of electricity, and that electricity should come from green sources. With all these things, experts put it at about, even if you take a very liberal view of things, we're at about $3.50. Now, the bridge between 3.5 and 1.5 is very huge in the industry. Now, here, Mr. Atanu Mukherjee says you can produce clean hydrogen. Let me not call it green hydrogen, but you can produce clean hydrogen at a cost of $1.25 a kg. That's a very, very important thing for us.
Let's come to the crux of the discussion today. Can you elaborate a bit on the scheme that the government has announced?
Yes. It's as you yourself mentioned in the opening remarks, it's a 37,500 crore scheme meant to provide incentives to projects that put up coal gasification. And by the way, this is surface coal gasification. Now, you must realize that when you think of coal gasification, you must mentally make a distinction between underground coal gasification and surface coal gasification. As the name suggests, underground coal gasification is where you gasify coals that are in deep seams, very difficult to get at. I mean, you can't mine the coal. Even if you want to mine the coal, it's very difficult to mine it properly, impossible to mine the coal. So what do you do with that coal? You gasify it. That is underground coal gasification. But this is surface coal gasification. Surface coal gasification does not mean that coal is there on the surface. It is just that the coal seams are not too deep. You can remove the overburden, and then you can get at the seam. This is called open cast mining. Everybody knows this. And you gasify that. That is surface coal gasification. Now, this scheme, this 37,500 crore scheme, is specifically for surface coal gasification. Why this is important is, earlier, in I think January 24, the government had come out with another scheme worth about 8,500 crores, under which I am told there are 8 projects running currently, 8 projects announced. I don't know to what extent they have started work. That does not make a distinction between surface and underground coal gasification. Now, the nuance here is underground coal gasification is still an unproven technology. It is still more or less in the realm of R&D, anywhere in the world, not just India. And there is only one commercial scale underground coal gasification plant, which is in a place called Angren in Uzbekistan. Everywhere in other places, there are pilot projects or R&D projects, but none on the commercial scale. So leave that aside. Surface coal gasification is what is doable, and many countries are doing it. Now, these two schemes seem to run parallel. The earlier 8,500 crore scheme, under which 8 projects have been announced and will start, and the new one. In the new one, since the government has specifically said this is for surface coal gasification, the hidden message in that is that the government has consciously separated underground and surface coal gasification. It's a recognition that let us not waste our time too much on underground. If the projects have been announced, let them take their own course. But let us now try under surface coal gasification. The government press release itself highlights the importance of this scheme. Well, let me read out from that. The scheme marks a major step towards accelerating India's coal or lignite gasification program, advancing the national target of gasifying 100 million tons of coal by 2030, strengthening energy security, and reducing dependence on imports of key products such as LNG, more than 50% imported, urea, 20% imported, ammonia, 100% imported, and methanol, 80 to 90% imported. That is the importance of the scheme. If this takes off, as we all hope and expect it will, then you can substantially reduce our dependence on imported material, and it's truly energy Atmanirbharata.
Should we read anything into the timing of the announcement? Because we've been struggling with what's been happening with West Asia and the consequences that will be inflicted upon us. Is there anything to read between the lines here?
You see, this coal gasification, the idea of coal gasification did not start after this crisis started. Now, we've been talking about it for decades. Now, since early 2000s, we've been talking about a Talcher project. We'll discuss that in a little while. So, it will not be proper to think that the entire planned program has come up because of the crisis in the Strait of Hormuz. But it is highly probable that the crisis has imparted a sense of urgency, has catalyzed the whole thinking and made it faster.
As with any process or something that's been mooted anew, I'm sure there are challenges to this
Oh, yeah, you
process.
bet.
Can you elaborate on some that are key?
Oh, yes. You see, I know this from talking to experts. The very critical thing about coal gasification is to marry the right technology to the type of coal that is the feedstock.
The determination of the success of a project at large scale depends totally on what kind of coal you have got. And therefore, it is extremely important to understand the nature of the coal. Indian coal is very different, as you know, very, very different than the other coals outside generally available where gasification has worked at large scale. For example, if you look at United States, and some other places. So it's very important. And of course, in other like South Africa, for example. But it's very important to have the right technology set for the techno-economics to work on the kind of coal that you have. And we said that, therefore, it is important to understand that Indian coals, any gasification technology, has got to be something called a non-slagging gasifier, which basically means that I don't melt the coal. If I melt the coal, given the very high ash content and the nature of the ash that Indian coal has, the likelihood for that to operate is remote in terms of it'll operate, with fits and starts. But at large scale, you want continuous operations and you want to make sure that the coal is matched to the technology, and that's when you move forward.
Now, earlier you might remember that there was this Talcher project conceived in the mid 2000s. It morphed into many forms, and then finally it actually started in about 2017 or 2018. They say it is now about, by the way, it is being put up by a consortium of 4 public sector companies, GAIL and so on. 13,000 crores it was when it was conceived. The idea was to produce coal gas and then to produce fertilizer from that. The company is called Talcher Fertilizers Limited. Now, the government says it is about 71%, 71.5% complete. But then there are disputes with the primary contractor, which is this Chinese company, Wuhan Engineering, and so on. It's not taking off. Now, this project's failure, it is too early to call it a failure, but this project not taking off properly in the manner that was originally envisaged has sort of put a negative blanket over the entire coal gasification issue, which is very unfortunate.
Lignite will work, and the economics should work. If the right kind of entrained flow gasification. So here is the problem, right? That happens. Any EPC contractor who builds this plant, they also know the risk, right? They know, right? And the technology provider also knows the risk. That look, this is a risky project because we know on high ash coal or low rank coals as it like is more challenging and may not work. So their risk premium in terms of the charge that they take on the EPC contract is very high.
The problem with Talcher project was that they unfortunately chose the wrong technology. This is not my judgment, and this is what I'm told by experts. And experts pretty early on alerted the project proponents against the type of technology that they had chosen, which is, by the way, called entrained flow gasifier technology, where the ash in the coal melts and then it is taken out in liquid form. Now, for very high ash coals, for technical reasons, this entrained flow gasifier technology is not appropriate. So it didn't get anywhere. I'm trying to answer your question. What is the issue? There are many ways, many technologies for this. There is fluidized bed technology, there is bubbling fluidized beds, and so on and so forth. We don't have to get into technicalities here. There are multiple technologies. You have to be very, very careful to choose the right technology for the type of coal that we have. If there is even a slight mismatch, you will end up something like this Talcher project. Now for Talcher project again, they are thinking of mixing pet coke. Pet coke is the thick residue that remains at the bottom of crude oil refineries. So India produces pet coke, but it also does not produce enough of it. So we still import pet coke. Now the project project proponents are thinking of mixing that coal, the Talcher coal, with pet coke, so that it brings down this viscosity of the ash fluid. When you do that, it kind of militates against energy self-reliance. After all, you still once again have to go abroad for the raw material, at least a part of it, and then it adds up to the cost. So it is meandering on like that. Now we should be very careful that the future project don't end up like that. The key issue is, again, I'm reiterating it, the key issue is the selection of technology, and you have to take it very, very carefully for the quality of coal, marrying it with the quality of the coal that you produce.
Just one more question. You probably already answered that, but in case you want to summarize. So given the stumbling blocks that we faced in the past, what is the future of coal gasification in India?
Well, I think it will work in the long run. I'm not at all in any doubt in my mind it will work. We will stumble along for some time, and then we will learn, and then we'll do. The question is, how do we reduce the time that we take to learn this? We are in a state of emergency now. We don't have too much. We don't have the luxury of taking enough time to learn. We have to learn quickly. We have to learn on the hoof, and then get there.
When you say learning, matching the technology required for the feedstock?
Yes. Essentially, that seems to be the case. Which technology for which coal, there you can't afford to make a mistake.
But over these last 1.5 to 2 decades since the Talcher project tried to go on stream, hasn't the learning been complete?
Well, there has been learning. As I said, they have realized that you can't use this coal in the kind of gasifier that they have. They're trying to bring in. So they're mixing pet coke in it. So now for newer types of coals, there may be different technologies more appropriate. So the learning has been there. Again, unfortunately, we've taken too much time in learning itself, which is not an unforgivable crime. One can be forgiven for that, but we must also realize that going forward, we don't have that much time to do that. Energy self-reliance, energy Atmanirbharata is something that we need very urgently. And here we have our own coal, and we need this coal for a good 2-3 decades until perhaps thorium comes into play. Now coal is our biggest energy mainstay. The other energy mainstay that we have in abundance of is thorium. Now, very recently we cracked that thorium technology, the fast breeder reactor, which can lead on to the use of thorium. But for thorium to become mainstream, you have to give it a good 30-40 years. There may be small plants here and there, but for that to become ubiquitous, you have to allow about 30-40 years of time, or even 50 years which is not bad, considering that the thorium that we have can provide us enough energy for millennia. What is 50 years when you're talking of 1,000 years of continuous supply of clean energy? So we will get there eventually. But until then, what do we do? The next 30-40 years, we have to make use of the coal that we have. We have to become energy self-reliant. We have to make use of coal. And this by far is the only way you can do that. So to answer your question, the future is there with the coal gasification. We will crack it, we'll get there. We have to do it fast.
Thanks to our earlier discussions that you and I have had, I understand that thorium is in reference to nuclear energy, which is also looked upon as was one form of clean energy.
Oh yes, it is. Oh yes, it is. Very much.
Awesome, Ramesh. It's been highly enlightening few minutes. Truly appreciate your coming in at such short notice.
Thank you very much.
See you again soon.